We've been talking about systems of linear equations, and we've mentioned that the solution to a system of linear equations is an xy coordinate because you need an x value and a y value that will fit into both equations. Today what we're going to do is talk about two different ways to algebraically solve a system of linear equations. The first one we're going to talk about is elimination. Now the idea behind elimination is that you temporarily eliminate one of the variables in order to solve for another, and then you replace it back in to find your coordinate. Let's take a look at the first example. Here we have a common term between 4x plus y equals 17 and 2x plus y equals 11. Now I find that if I subtract the second equation from the first, I'm left with 2x equals 6. Why is that? Because I have a positive y and then I'm subtracting another positive y from that original one, and the y's are eliminated, hence the term elimination. So that leaves me with 2x equals 6. Solving for x, I see that x equals 3. Now I'm not done because I'm looking for an x coordinate and a y coordinate. The y has been temporarily eliminated, but that doesn't mean it's gone forever. Now it just means that x equals 3, so I can go ahead and take that x equals 3 and plug it into the first equation. Now it doesn't matter, I could have plugged it into the first equation or the second equation in order to solve for y. And then what I see is that y equals 5. So now the answer to this equation is the coordinate positive 3 comma positive 5. Now a good strategy or a good suggestion is to plug this in to both equations just to check your work to make sure everything makes sense. So if I plugged it into the first equation, I get 4 times 3 plus 5 equals 17. That's true. Also 2 times 3 plus 5 equals 11. So just a quick check to make sure that your answer is right. Now sometimes there's no common term. It's not really straightforward in terms of being able to see what can or can't be eliminated. I do have 2x plus 3y equals 7 and x plus 6y equals 8. There are two different things you could do. What I'm going to do is go ahead and take this first equation and multiply everything by 2. So that's going to get me my new equation of 4x plus 6y equals 14. And then when I combine that with my second equation, x plus 6y equals 8, what I get is that I now can subtract the second equation from the first. To work on the problem, I have 4x minus x, which gets me 3x. The 6y's cancel out, and then I'm left with 14 minus 8, which is 6. So in this case, x equals 2. Now I don't have to go back, well, I still have to go back and find what y equals, because remember I need an x and a y coordinate, but I can go ahead and plug into my second equation over here. I know x equals 2, so I'm going to say 2 plus 6y equals 8, and then I'm going to go ahead and solve for y. I subtract 2 from both sides. 6y equals 6, and y equals 1. So the answer to this second system of equations is positive 2 comma positive 1. And when I check these numbers into the original equations, I see that my answers are right. That's how to use elimination. Now another method is to use substitution. Now in substitution, you rewrite one equation in terms of the other variable, and then you from the first equation, and then you plug it into the second. So in this case, my system of equations is y equals x plus 3 and 2x plus y equals 15. Well, in this case, I know that y equals x plus 3. So what I'm going to do is plug in x plus 3 for y in the second equation, which gets me 2x plus, now instead of y, I'm using x plus 3, equals 15. And then I'm going to go ahead and solve for x. So this is 3x plus 3 equals 15, and I subtract 3 from both sides. 3x equals 12 and x equals 4. Just like with elimination, you have to go back and solve for the y coordinate. So if I know x equals 4, I'm going to go back to my original equation here. Since y equals x plus 3, I'm just going to say y equals 4 plus 3. So y equals 7. So then the answer here is positive 4, positive 7. And when I check the values, y equals 4 plus 3, I know that 7 equals 4 plus 3, that's true. And 2 times 4 is 8, 8 plus 7 equals 15. So quick check shows that this answer is correct. Now in some cases, you have to do a little work to substitute one term in for another. So in this case I have 7m plus 2n equals negative 8. 2m equals 3n minus 13. So the first thing I'm probably going to do is take this 2m equals 3n minus 13 and I'm going to divide everything by 2. So I get m equals 3n minus 13 over 2. And then I'm going to take this value and substitute it into the first equation, which gets me 7 times m. Now for m I have 3n minus 13 over 2 plus 2n equals negative 8. Alright, so I can go ahead and multiply everything out. Notice that 7 is pretty much the same thing as 7 over 1. So I'll multiply straight across using the distributive property. And I get 7 times 3 is 21n minus 7 times 13, which is 70 plus 21, so 91 over 2 plus 2n equals negative 8. Alright, that starts to get a little ugly, but I can go ahead and get rid of this fraction by multiplying everything by 2. These 2's cancel out. Remember, this is multiplied by 2 and this is multiplied by 2. So that's going to get me 21n minus 91 plus 4n equals negative 16. Alright, I have 21n and 4n. That gets me 25n minus 91 equals negative 16. And then I add 91 to both sides. And I get 25n equals 75. Haha, very convenient, isn't it? N equals 3. Now I know that n equals 3. I can go ahead and plug it back into one of the original equations here to solve for m. But you know what? I could also take this n equals 3 and plug it into this equation since it's already set up in terms of solving for m. So I could say m equals 3 times 3 minus 13 all over 2. So m equals 9 minus 13 over 2. And so then m equals, if I hopefully don't run out of space, m equals negative 4 over 2, which means m equals negative 2. So as I look at my answer here, I have n equals 3 and m equals negative 2. Now, in this case, substitution was definitely not the easier way to go. In this first example, you could see that it made sense to go ahead and use substitution. In the second example, maybe substitution wasn't the best way. You're going to be given some systems of equations and you're going to have to decide whether substitution or elimination is the best way to go. So first is your challenge problem. You can solve this by using either elimination or substitution. Elimination or substitution will work. You can do it both ways. One way is easier than the other. In order to figure that out, my hint to you is to first eliminate the fraction and then see what you have left.